Hello everyone. I have this adorable little alarm clock. As you can see, when I try to make it work, nothing happens. It's completely dead, which means the battery inside is probably flat. A loose battery could also be the reason the alarm clock isn't working. I reinserted the battery, but the alarm clock still didn't respond. I have a new AA battery. I'll try putting it in the alarm clock. The alarm clock starts working immediately. The main reason is that the battery is dead. To confirm my suspicions, I'm grabbing my trusty multimeter. I'll set it to measure voltage and test these batteries. Let's check the first battery. It reads a healthy 1.59 volts, which is exactly what we want. I quickly marked it to avoid confusion. I used a marker to write a V for the battery with good voltage. Here's the dead battery from the clock. As you can see, the reading is 0, confirming this battery is totally flat. I'll mark it with an X, so I don't confuse it with working ones. So we have a good battery and a dead one. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Let's bring this battery back to life. I'm taking a glass and adding some salt to it, about 2 spoonfuls. Then, I'll pour in some fresh water. The salt dissolves and creates an electrolyte solution, which is key for our revival process. I'll stir it well to make sure the salt is fully dissolved. Next, I'll place a few metal keys into the salt water. These metal keys will act as electrodes in our solution. Now, I'm gently placing our dead battery, the one marked with an X, into the glass as well, ensuring it's fully submerged and touching the keys. We'll let this sit for a while, allowing the electrochemical reaction to take place, giving the battery a chance to reactivate. I'll give it an occasional stir to help the process. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. After a while, you will see the water change slightly in color, indicating that a chemical reaction is taking place. I'll carefully take out the battery and keys, and then wipe them thoroughly with a clean cloth to remove any residue. Now for the exciting part. I'm going to use a lighter to quickly heat the positive end of the revived battery. Watch closely. See those sparks and the small flame? That's the concentrated energy showing the battery has been reactivated. After a quick clean of the residue, I'll test the battery again with my multimeter. And just like that, we're getting a reading of 1.50 volts. Our seemingly dead battery is now alive and ready to use, all thanks to a simple household hack. Let's put our revitalized battery back into the alarm clock. And there it is, ticking away perfectly. This old clock is fully functional again. For our next project, I'm going to turn this small digital display into a miniature temperature monitor. I'll open up the back compartment. These little batteries provide enough power for this low-energy module. After closing the lid, you'll find it still doesn't work. These batteries may be dead. I used a pen and marked an X on the back of the two dead batteries. I have two other button batteries here. I put them into the electronic thermometer and it worked immediately. This shows the main cause was a dead battery. To confirm my suspicions, I'm grabbing my trusty multimeter. I'll set it to measure voltage and test these batteries. Let's check the first battery. The first battery had a voltage of only about 0.01 volts, which was very low. I checked the second battery and it was the same. That's practically dead, which explains why our electronic thermometer wasn't working. Now, let's create a simple DIY USB contact charger. I'll take an old USB charging cable and cut off the end that normally plugs into a phone. Then, I'll carefully strip the insulation from the internal wires, exposing the copper strands. After plugging the USB charger into a power strip, I'll use my multimeter to test the voltage coming from the USB charger. As you can see, we're getting a stable reading of around 5.28 volts, which is the standard output for USB charging. To ensure safety and create a more robust device, I used red electrical tape to cover the stripped wire ends. I attached one end of the battery to red electrical tape. This will insulate the contact points and keep everything securely fixed. I connected the USB charger to the power source and started the charging process. I will touch the other end of the wire to the other terminal of the battery to charge it. I repeated this process with both batteries that were completely depleted. This DIY contact charger is perfect for charging small electronic devices that might not have a conventional charging port, or for creating a quick, custom power solution for your projects. You can adapt the contact points based on your specific needs, making it quite versatile. Time for one last check. I used the multimeter again to check the voltage of the two restored batteries. And there it is, a good 1.56 volts. And I checked the second battery and it was at 1.60 volts. From almost completely depleted to almost fully charged, this little trick really worked. It's great to see it's been successfully restored. I reinserted the two charged batteries into the digital thermometer. It's working again. If you enjoyed these projects and found them inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me which hack was your favorite. Thank you for watching,